Hey everybody. Today I'm analyzing some data from a recent Floristic quality assessment that I was involved in. In this study, 3 different teams of students went out and collected data from 3 different natural areas: a ravine, a savanna, a wetland, and a prairie. And each of the teams of students laid down a couple of plots, 1 square meter by 1 meter by 1 meter, so 1 square meter total. And then they surveyed all of the different species of plants that they found within those plots. And you can see those species names listed here. Each team had a spreadsheet that they filled in, and the spreadsheets were a copy and paste job. So you'll see they all have the same number of columns, and they all have the same column names. So that's going to be something that works in our favor. On the other hand, the students input the data somewhat differently. So for instance, team 1 left some blank space here and there. It's an Excel spreadsheet. They thought that would look nicer. I think they were probably right about that. But for data analysis, it's a little bit annoying. Team 3 decided that they didn't have to fill out the entire column with their team number or the entire column with the date. And you can see, for instance, for plot, it goes 1A all the way, followed by NAs all the way down to 1B, missing values. It makes perfect sense. We can assume these are all 1As, but R won't know the difference between this being a 1A that we know is a 1A and it just being a plain missing value. So we'll need to go back and fix that. Well, let's jump right in. Let's bind these sets together because they all have the same column names. We can do that just with an rbind command. Let's call the new data set FQA data, and it's just rbind. And I want to do team 1, team 2, and team 3. And we can view that. There we go. All right, so notice that we have 265 entries now. Each of the other spreadsheets only has 80 or 90 entries. Great, so I'm going to go ahead and close up these other windows. So the thing I'm mostly going to be interested in this vid is the C values, just by the way. And what's going on here is that each species that's considered native to the region, in this case, Northern Illinois, the Chicagoland region, has been assigned a number between 0 and 10, the so-called coefficient of conservation. And this is supposed to be an indicator of how likely the species would be to be found in an untouched sort of ecosystem. Zeros tend to be the sorts of plants that might grow out of cracks in driveway or in cement, whereas 10s are plants you would probably only find in remnant pieces of wilderness, stuff that's untouched or in a state of excellent management. And I'm going to want to ask questions about the distributions of these C values in the different transects. So I'm going to have a little bit of cleaning to do on that column. First, I want to deal with all of these NAs. So let's take the FQA data set. I feel like it's okay to overwrite it for the next things I'm going to do. And by the way, my standard for when it's okay to overwrite a variable I already have is, if I run the command again, is it going to break things? Are things going to give me the same answer as if I only ran the command once? Or will I get errors? Will I get values that have changed in weird ways? And in this case, things shouldn't particularly go wrong. So the first thing I want to do is to filter out these blank rows. And in particular, the standard I'm going to use here is whether species name is blank. I'm okay with that. I don't think I'm going to lose any data here because I'm specifically interested in the distribution of the different species and their C values. So if students didn't put in a species name, the entire row is going to be useless to me. So let's go ahead and take it out. I think they're all entirely missing rows, but I don't mind if there's some where it's just species missing. Hey, by the way, notice my pipe here is the vertical bar and the greater than symbol. That's the native pipe that was introduced in base R during 2020. The R community has gradually moved over towards that native pipe from the gritter pipe, the percent greater than percent. I've been on that bandwagon. Okay, so let's take the things that are not NA in the species name column. Okay. And then once we've done that, in the same pipe, I'm going to deal with these sort of implied values. And I'm going to do that using the fill command. The fill command is going to go through each of the columns that I'm going to specify and just fill downward. So the 1A will go all the way down through these NAs. The shooting star ravine will go even further down, and so on. So another pipe, and then fill. The first argument of fill is a data frame, so it plays nicely with the pipe. And now I need to specify the columns that I want to use. And I can use any of the syntax that select respects, what we call tidy select syntax. I want from team to plot number. Okay, oops, I want command enter there. And then let's view that data set again. Okay, so no more blank rows, and team 3 has been filled in nicely. So, there's one other thing I want to do here, and maybe you've already noticed that some of these column names have lowercase names at the beginning and then underscores, but some of them don't. Like transect name, there's a capital and a space. So transect name is actually a non-syntactic column name. If I want to specify it by name, I'm going to have to put it inside of quotes. I did the same thing with the quadrants here. And I want to fix that. Basically what happened is I wrote this spreadsheet and sent it out to the students, and then realized after the fact that I hadn't included a transect column. And so I added it after the fact, on the fly, right before the students went into the field. I wasn't thinking in terms of the syntactic names. While I'm talking about column names, let's mention quadrants. Each of those 1 square meter plots that the students had was divided with string into 4 quadrants, 1, 2, 3, and 4. And I asked the students to indicate which quadrants they actually saw the species in. And yeah, I know this isn't tidy. Probably it should be quadrant 1, 2, 3, 4 all the way down. And I knew that when I wrote the spreadsheet, and this was just a design choice. I wanted the students to be able to input their data in a rather efficient fashion and not have to potentially do 3 or 4 rows for every single species that they saw in a single plot. If I were going to look at quadrants, I would have to do a pivot longer on this. I'll throw a link to pivot longer up top. In this vid, I'm not going to deal with quadrants at all, though, so we can pretty well ignore that issue. Okay, so let's deal with the column names. I am going to use the clean names function from the janitor package. So library janitor. And then just in my usual pipe, I will put clean names. There may be other functions in the janitor package. I've never used anything but clean names. It's a nice individual function. And then if I view my FQA data again, you'll see it has made my uppercase lowercase, and it's made my spaces underscores. It does a number of other natural things to column names that you may have fouled up when you were getting ready to collect data. Okay, so now I want to deal with the C values right here. There we go. Okay, so you see that most of them are numbers, as they should be. There's also some NNs. That stands for non-native. So in this study, students were only interested in plants that were considered to be native to the Chicagoland region. And when they had a plant that was identified as non-native to the region, they put in NN. They were specifically asked to put in NN. There's also plenty of missing values here. So for instance, POA SP means that it's something in the genus POA, but they couldn't identify the species, and so they left that blank. That's all well and good, except for the fact that some students put in lowercase nn, others put in uppercase nn, and for the ones that were considered where they couldn't identify them entirely, some left the thing blank and some actually wrote in NA. And so R is going to deal differently with the NAs where students put in just the letters NA versus the ones where they left them blank. So ultimately what I'm going to want to do is to consider only the native species. So I'm going to want to filter out anything that isn't a number here. But before I do that, I want to find out how many of these are non-native, how many couldn't be identified. I'm a strong believer that you shouldn't just throw away data from your set without first considering it. What's different about these rows that we're about to throw away? What's interesting? This set would look very different if there were 1 non-native species versus if there were 1,000 different observed non-native species. Similarly, I'd be concerned if a lot of the species hadn't been identified. That would indicate that all the data might be bunk. So I want to get some summary values here. And in order to do that, I'm going to need to mutate my C column to fix these character vector NAs and to make these other NNs uniform. Okay, So FQA data, let's call it tidier. Let's not write over everything forever. So let's take FQA data and pipe that into a mutate command. I said I wanted to modify the C column. And I said I had a few different conditions, right? Like if I have the capital NN, I'm going to make it a lowercase nn. If I have a NA character vector, I want to make that an actual NA. And if I have a number, I just want to get a number back. I could do that with a complicated if-else, complicated if-else statement, but instead, I'm going to use the case when function. I think that's in dplyr. Yeah, dplyr, a general vectorized if statement. So basically, we're going to be able to use case when to give us different outputs based on the different conditions that may or may not be true. So the first thing I'm going to be interested in is if the C value is quote capital NN. And since I'm testing logical equivalence, I want to use a double equal sign. It's not naming an argument or making an assignment. And if I have capital quote rather capital NN, I want lowercase nn just for uniformity. The next thing that could go wrong is that if C is equal to NA, then I want to give back an actual missing value. And I'm going to go ahead and execute this, but you'll see I'm going to get an error. Let me make this visible. Yeah, caused by the case when part of this call. All right, so basically case when has to return a vector. So it's going to be returning an ordered sequence of things, all of which have to have the same type. One of the things that we don't usually have to think about too much in R is what the type of NA is. Technically, NA is logical, and you can see this very clearly if we do is dot, I don't know, let's start with character, NA, right? Because NN is character, so is NA character? The answer is no. On the other hand, if we do logical, we'll get true. So technically, the NA character that you know and love, or know and get annoyed by, is logical. We need an NA that is specifically a character, and we can specify that with NA underscore character underscore. So that'll fix that problem. Not something you have to deal with in R all the time, but it comes up occasionally. Finally, if neither one of those things is the case, then we want C just to be equal to what it was. So if neither one of these things happens, then we want just a catch-all here at the end. And the way that we specify that in case when is just with true. So true is always true, of course. And in that case, we should just return C. And I think we should be good to go here. All right, so let's just take another look at FQA. Oh, let's take a look at FQA data tidier now. And now our C values look like they should. And the reason I did that is because I want to get a count. So let's do FQA data tidier and literally pipe it into the count command. And I want to count how C breaks down. All right, so there's some good summary information about our C values. They're not exactly in the order I'd like. I'd rather have the 10 down at the bottom. But you can see that of our 250 observations, we have 50 that the students couldn't identify. So, you know, about 20%, not the best, but not the worst either. And 23 non-native species. All right. Now I am willing to throw away these 73 values and just look at the C. We'll get a distribution of all the C values that the students found. And we recognize that when we throw away 50 unidentified species, that we may be skewing our data in that omission. Maybe the species that the students couldn't identify happen to be the ones that are the most common to non-degraded areas that the students don't visit as much, presumably, in their ordinary lives. So maybe we're throwing away a lot of 10s here. But we've done what we can at this point. We're just going to live with that. So let's take FQA data tidier and overwrite this time what I want to do is to take this column of C values, which is a character vector, you can see that right here, and I want to make it numeric. So C should be as dot numeric of C. And this is going to introduce some NAs by coercion. I'm going to get a warning message here. That's fine. I'm prepared for that. It's actually what I want. And then after that, I want to filter it so that I'm only keeping the values where C is not an NA. All right, so there's that warning message that I said I was going to get. All right, so 177 entries. I threw away 73 values. That's what I was expecting. And you can see that now my C's are all just numbers. Great. Well, now I've got this distribution of numbers. I should visualize that, right? So ggplot, FQA, data tidier. I want just a bar plot. So let's let X be C. Let's take a geom bar. And right away, I'll do a theme minimal. If I can find it there. All right. So you can see, can I zoom in on this, please? Didn't quite work. Let me try that again. Y'all are so patient with me. There we go. Okay. So we can see that we've got a number of 5s here in particular. The places where the students were in the Lake Forest College area. It's not a degraded landscape, but it's also not exactly wild and untouched country. This plot is okay. My big quibble with it is that the labels on the bottom aren't quite right. 7.5 is not an actual C value. I don't want that. So before I move on, I'm going to add a scale X continuous. I'm pretty sure it's continuous in this case, not discrete. And I just want to specify some new breaks. And I want to do a sequence. I want to do it from 0 to 10 by, I don't know, let's try 2 and plus. All right, so that looks better. You can see that I no longer am trying to claim or seem to be trying to claim that there's a C value of 7.5 in there. Excellent. So the real thing that I want to do here, and maybe I'll put this in as a comment, is how do C values compare across sites? That is, across these different transects that we have. You can Google if you want to know more about transect methodology and floristic quality assessment. It's a little beyond the scope of this vid. So, we've got these different locations. Do some of them have plants with higher C values? Do some of them not? What's the overall state of conservation according to this metric here for each of those? Now, let's just get a count to start. So let's take FQA, data, tidier, and count by transect name. And here we're going to see an issue. There's only 4 different transects in this set. The students only went to 4 different places. But there's 11 different rows in this summary column. And you can see why. There were 3 teams of students that went out to the prairie, but they all labeled it something different in their spreadsheet. Here's prairie misspelled, and here's one where they put the actual name of the prairie in there, Reverie Prairie. So I need to fix that. And there's lots of different ways I could refactor this. I'm going to use just a mutate command, and it's a lot of typing. So I did this earlier, and I'll just show it rather than making you watch me type all of this in. So what I'm going to do is I'm going to take the FQA data tidier set that I have and just pipe it into a mutate, where I'm going to overwrite the transect name column. That's this one. And replace it using a case when. So if transect name is prairie without the second I, then I'm going to replace it with prairie with the second I, and so on down the line. I've decided that all of my wetland would be labeled just wetland singular. I don't know which one it's really supposed to be. As long as it's consistent, I'm okay with it. Okay. So feel free to pause the video if you want to look at that a little more closely. I'll also throw the whole script up on my GitHub, so there's a link down below. You can chase that down if you'd like. Let's redo this count command, and hopefully we should only get 4 different transect names there. And we did. You can see that in the 4 different areas, the students identified roughly the same numbers of species. So that's what we call species richness for these plants in these areas. A couple more in the savanna, a few, slightly less in the prairie. Great. Let me get a slightly more robust summary table now. So let's take the FQA data tidier set and let's group it by transect. In hindsight, I probably could have called that transect name. Oops, but it's fine. And then let's do a summarize. Let's get the mean C is going to be the mean of the C values. I don't need to do any sort of na.rm. I don't need to remove any missing values because I already know there aren't any. Let's do the standard deviation of the C. And then let's also keep track of the count. And we can just do n parenthesis. There's that helper function there. And I'll just go ahead and print this out. Okay. So I have these 4 different things. I've got the mean C. I've got the standard deviations. You know what? Before I say anything else, let's arrange this by the mean C. Just make it a little bit clearer. And I want it decreasing. So let's put a negative sign in front there. That'll reverse the order. All right, so of the 4 locations that the students visited, the wetland had the highest mean C, followed by the ravine, the prairie, and the savanna. Notice that the wetland had slightly more spread, measured by the standard deviation, while the savanna, which had the lowest mean C, also had the highest richness, had the highest number of distinct species. Let's get a visualization on this, and then we'll do probably an ANOVA to see if the differences between these groups are statistically significant or not. So let's take the FQA data tidier. On the x-axis, I want to put the transect name. On the y-axis, I want to put the C value. I'm not just trying to plot the mean for these. I want to plot all the data points, or at least some sort of summary of the data points. And let's get a geom box plot. Start with that. Transect names. All right. And let's get a theme minimal, and then I'll zoom in on it. I don't know why I forgot to do my theme minimal at the beginning of this vid, but I did. All right, I'll zoom in on that in 1 sec. I want to do one other thing first, actually. Box plots are great as summaries, but they don't show individual data values, so they can potentially be misleading. For instance, if the sample sizes in the different groups are really different. So what I want to do is to actually overplot this with the individual data values. And I'm going to use a jitter on this. And I'll do a width of 0.2 to make them a little tighter. Let's see how that looks. Okay, that looks pretty good. So you can see the individual data values here, as well as the overall trends in the data. And looking at this, you can see that the box for the wetland is higher. And the median here is about as high as the 75th percentile for the other groups. So there's this apparent trend that the wetland does have higher C values. We shouldn't just take that on face value. I think visualizations can be tremendously helpful for understanding data sets, but they also can lead us to draw some conclusions with too much confidence. Like here, we seem to be seeing a trend. Let's see what actually an ANOVA has to say about this. So an ANOVA is just a linear model, so we can save that model as I'll call it model. The response variable here is C, and the explanatory variable is transect name, not names. and the data is FQA data tidier. And then let's get the summary. Summary of the model. Haha. And let me make that print a little more nicely. Okay, so we've got the whole ANOVA table. The thing that I really want to point out here, it's still not quite printing the way I want. There we go. Is right here. The p-value for this ANOVA is only 0.04. So that's small, technically statistically significant at an alpha equals 0.05 level, but it's not exactly minuscule, right? This is that there's a 4% chance of getting data like this if in fact all the groups are identical in terms of the distribution of C values, with some pretty usual assumptions on the distributions of the data. So this trend that we thought we saw pretty clearly in the data could actually be due to random chance, a 4% chance of a false positive here. And I think that's actually a lot more clear to see. I'm going to go back and do one more ggplot here that I think illustrates that. I'm going to do the same box plot that I did a second ago, but now I'm just going to leave in the points. I'm just going to leave in the jitter plot, not the boxes. And did I leave out a plus sign? Yes, I did. Okay. So now without the boxes to make us draw some conclusions and point us in certain directions, it's a lot less obvious that the wetlands tend to have higher C values. These distributions overlap a lot more than you might have been led to believe just by looking at that box plot. All right, everybody, that's the end of this vid. I hope you got some good stuff out of it. Bye-bye.